Okay, so example number one. If we look at this strip here, the first thing we want to look at is regularity. So are these R to R intervals consistent? So here's an R wave, here's an R wave. And so if I kind of count how many boxes between, 1, 2, 3, 4, 5 large boxes plus about 5 small boxes more, so that's 30 large boxes. At first glance, it all appears regular, but you can always double check just to make sure that your instinct is correct. So count again, 5, 10, 15, 20, 25, an extra 4, an extra 1, that's 30. So yes, so R to R is regular. So this is a regular rhythm. Now, when we do rate, there's obviously 3 different ways that you can do rate. I said this is a 6-second strip, so the easiest way to do rate on a 6-second strip is count how many R complexes you have. 1, 2, 3, 4, 5, multiply by 10, so we have a rate of 50. You could also use the rule of 300. So with that one, you're going to count down kind of using your large boxes again. So this one is pretty close to a large box line. So I would say this is 300, 150, 100, 75, 60, and that would be 50. So again, that started one before, that ended one before. So we're coming up with the same rate, 50. You could also use that 30 small boxes in between your R complexes and do 1500 divided by 30. And guess what? You come up with 50. So the rate checks out any way that you do it. Our heart rate is 50. So this is slow. So anytime you find something abnormal, you want to make a note of it because that is going to play into what you're going to interpret your rhythm as. So rate, regularity, P waves. We have nice, beautiful P waves. They are round, they are upright. So these are nice, beautiful, expected P waves. If we measure our PR intervals, so this one starts right here and it's going to end right here. It's about 5 small boxes or 0.20 seconds, so that is within normal. If we measure our QRS duration, here I'll measure on this guy right here. He ends right there on that dark line and starts right here. So that's just about three boxes, 0.12 seconds. So that's also normal. So far, the only thing we found that is abnormal is our rate. Now, do we have one P wave for every QRS, one QRS for every P wave? Yes, we do. We don't have any extra P waves anywhere. We don't have any extra QRSs anywhere. This right here is our T wave, so it's kind of delayed compared to where we typically expect to see it, but it's not a P wave because when you look at it, it doesn't look the same as your P wave. So it is a different kind of electricity. It's coming from somewhere else in the heart. So P waves should always look the same. So the only thing we have abnormal here is that it is a slow heart rate. That means it is a sinus bradycardia. The only thing abnormal is the rate. All right, let's go through those same steps here for practice strip number 2. So regularity at first glance, it appears fairly regular to me. I could see somebody making an argument that maybe these R to R's here and here are a little bit closer together than these R to R's here and here. So I'll accept probably whichever way you want to go with it. For me, when I'm glancing at the monitor, which is how you're typically doing regularity, it should stick out at you like a sore thumb when it's irregular. So this would technically meet criteria for being irregular because it's greater difference R intervals of 2 small boxes, but I would call it regular for our purposes. It's not a huge difference. So it's regular. What's our rate? Well, our rate is 70. We've got 7 R complexes here on our 6-second strip, so we could double check that any way that you want to, and it should come out about the same. Do we have P waves? Yes, we do. They are upright and they are round. They are beautiful looking P waves. Can we measure our PR interval? We sure can. Let's find a good one here. This one's good. So it starts right on that first line past the dark line, and it's going to end right here as the QRS starts. So about 0.16, maybe 0.20. Either way, it's within normal limits. Our QRS is also nice and narrow. I would say maximum 0.08, probably more like 0.06. Do we have one P wave for every QRS? We sure do. So that's a nice normal P to QRS ratio. T waves are upright. We do have an abnormality here. If we try to draw our nice straight line across, our ST segment is depressed. It is below that baseline. So our ST segment is depressed. Remember, that doesn't change your rhythm interpretation. It's just something that you add on to your interpretation after the fact. So this is a sinus rhythm. We've come up with perfect P waves that always conduct to a QRS. I said this was a normal sinus rhythm. You could argue that it's a sinus rhythm with ST depression, or you could even go with sinus arrhythmia. It's the art of interpretation. So as long as you have something that justifies your answer, that your individual steps are lining up to the answer you select at the end, I could see your argument either way on those. All right, here's another good rhythm for us. So regularity, it looks regular. Our R to R intervals here are definitely very similar, all the same, nice equal spacing. So it is a regular rhythm. Our rate is fast though. So as we approach these faster rates, it can be burdensome to try and count out 15, 16, 18, 20 plus R complexes in 6 seconds. So that's where using your rule of 300s or your R to R method for calculating rate can be more useful. So if I look at this one here, lost my mouse, 1 second. If I look at this one here, so if I say this R complex starts right here, that would be 300. That would be a rate of 150. So we know the rate is somewhere between 100 and 150 based on the rule of 300 and probably closer to 150. So I'd put the rate at about 130 if I double checked that with our math. So we'd say that is 5, wait, where is it? This one. 5, 10, 11, 12, 1500 divided by 12. That comes out to a rate of 125. So not bad using my R to R and my rule of 300. So it is definitely a tachycardic rhythm of some sort. Do we have P waves? Yes, we do. They are beautiful, they are upright, and they are round. Every P wave is followed by a QRS. There's no extras anywhere. So we have a good P to QRS ratio. If we measure our PR interval, it's about 3 boxes, 0.12. If we measure our QRS duration, it is also about 3 boxes, 0.12. So everything is checking out except the rate. So this is a nice sinus tachycardia. Now you say, but what is going on over here at the end of this rhythm, right? What is this? Well, that's the patient moving. That is a type of artifact. So artifact is never going to change your interpretation of a rhythm. What artifact does is tell you to be cautious of what you're looking at, because as your patient moves, it can mess up what you are interpreting. So obviously this completely moved the baseline of that EKG. So you want to tell the patient to hold still, especially if you're trying to get a 12-lead EKG at this point in time. You need a nice straight baseline without that patient moving in order to make an accurate interpretation. All right, here's another strip right here. So off the bat, it looks regular. We've got R to R intervals, nice and equally spaced. Everything is marching out beautifully. So it's regular. Our rate is going to be about 60. So if you wanted to say, is it 59 or is it 60? You know, what's it going to be? Do I have to do the math? Realistically, your monitor will tell you if it's 59 or 60. And remember, it only matters if the patient is truly symptomatic. So we could do the math just to be safe here. 5, 10, 15, 20, 25, about 26 small boxes in between our complexes. So 1500 divided by 26. The rate comes out to 58, so just below 60. All right. Do we have P waves? Yes, we do. We do have P waves. They are nice. Oops, they are round. They are upright. Every P wave is followed by a QRS complex. Every QRS is preceded by a P wave. We can measure our PR interval because they're all the same. So it looks to be about maybe 0.112 to 0.16. In either case, it's normal. We can measure our QRS duration. So there's the start, there's the end. Just over 2 boxes, so maybe 0.10, 0.11 within normal limits. So the only thing that we have abnormal is really the rate. But if we try to draw our horizontal line here across our TP and our P segment, just a nice straight line, we do see that that ST segment is a bit elevated. It's a bit above the baseline. So remember, that doesn't change your rhythm interpretation. It's just an add-on. So this is a sinus rhythm with ST elevation, or you could say it's a sinus bradycardia with ST elevation if you went with that heart rate of 58. Just make sure that your individual step-by-step interpretation matches your answer at the end. And our last strip that we'll do here together, let's look at it just off the bat. This one looks irregular. Irregular. that is not good, right? Our R to R interval is definitely not the same, not consistent. So that is a red flag for us. So now let's just go through and say, is it a sinus rhythm though? So do we have P waves? We do. There's some round P waves. They're small, but they're there. They're round and they're upright. It counts as a nice, beautiful sinus P wave. Every P is followed by a QRS, then a T, P, QRS, T, P, QRS, T. So our P to QRS ratio is good. We can measure our PR intervals. See this one here, right there to right there, somewhere between 0.12 and 0.16. Our QRS is also nice and narrow, about maybe 0.4 to 0.04 to 0.06. Our baseline is good, so no ST segment deviation. Our T wave is good. So really the only thing that we have abnormal is it's irregular. So if every P wave looks the same, but you have irregularities, that is a sinus arrhythmia. So hopefully those examples help you out a little bit as you're looking through your homework and your quizzes. Have a great day.